the laws of physics themselves, obviously, if you look back at the days of Descartes onwards, Descartes obviously employed a lot of maths for his laws of physics in terms of a mechanical universe. Descartes thought that God was a mathematician. Um, the laws of physics are also, to a certain extent, a hangover from theological views of God in terms of religious laws that govern the universe and existence. In the contemporary world, let's say, people to a certain extent still use the metaphor of governing, of causal powers, of generating mechanisms, but they've removed the concept of God from the laws of physics. So, and there's obviously lots of work in this philosophical area from people like David Lewis, Armstrong, Alexander Bird, and Barry Lower on the laws of physics in terms of the philosophy of physics. But as a leading and internationally known cosmologist, first of all, tell me what the fundamental laws of physics are and what you understand them to be.
There's an underlying layer of structure, which is that we nowadays, all of laws of physics are taken to be either Lagrangian or Hamiltonian.
Mm.
And this is a generic kind of formulation which you can use for any laws of physics, whatever. And so that's taken by Theoretical Physics Foundation. Then you've got Maxwell's equations for electromagnetism, which are central to everyday life. You've got quantum physics, and that's the Schrödinger equation or Dirac equation, depending on context. And then you've got Einstein's equation of special relativity and general relativity, which is gravity. However, what works out in particular context depends on that context. So an interesting question is, so where are Newton's laws of motion? Because all engineers and so on use Newton's laws of motion all the time.
Mm.
They have to be implied by the ones I've just talked about. Newton's law of gravity is implied by Einstein equations. That's quite clear. But in fact, if you are an engineer or an architect, you don't need Galileo's law of Newton's law of gravity. All you need is Galileo's law of gravity, which is basically things accelerate down to the Earth at 32 meters per second, and there is a certain stress on a structure due to gravity. So there are what you might call the fundamental laws, but in fact, in practice, in most daily life stuff, quantum physicists, you use that, but ordinary engineers and physicists, well, engineers and architects, as I say, would be using Newton's laws of motion and Galileo's law of gravity. It actually is an interesting question how Newton's laws of motion come out of the other ones. And I don't actually recall having seen a very clear statement on that, but it obviously is possible.
That's interesting as well. Also, the ones you mentioned there, the obviously the Hamiltonian equations, the Schrödinger equations, Einstein's equations for gravity. Obviously, special relativity itself isn't necessarily a law; it's a theory. We won't get into that right now. Just off the bat that struck me there quite accordingly. So well, the fundamental laws in that respect is quite interesting because the first three that you mentioned are all equations. So before I get you to discuss how laws are metaphysically primitive, what does the role of mathematics say in constructing the laws of physics?
Um, well, people have tried to work this out, and it's just a simple fact that nature is constructed. Mathematics is the language of nature. So the laws themselves are they describe the behaviors of matter, but it isn't as if somewhere there is FSMA written in some abstract space. The mathematics describes what the laws do. And so when we talk about any of these equations, we are talking about our representation of what those laws do. So we're talking about our representation of them. And for that, mathematics is essential.
Would you say it's also quite instrumentalist as well? It's clearly representing our perceivable reality to us. But would you say it's also quite an instrument as well? Obviously, in philosophy of mathematics, there's disagreements between fictionist accounts and Platonic accounts of mathematics. So the laws describe and represent our perceived reality around us, and sorry, um, the maths represent and describe the reality around us. Would you also say the mathematics is an instrument in that respect?
Yeah, and just for the record, I am a mathematical Platonist. I think like all working mathematicians.
You're a mathematical Platonist, but you just said you didn't think they exist in an abstract space. So I may be missing something here. So clear this up. So name me any number, any formula in a Platonic sense. Do you think that exists independently in itself somewhere?
Yes, like the number pi,
Yeah. Okay.
or the fact that the square root of 2 is irrational. And I mean, I'm sure you're familiar with this. Mathematicians don't make this up. It's not a social construction.
No, 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 no. We won't
It's
even get
it's
into that. No,
it's
no, no. Continue, George. Yeah, yeah.
it's something they discover, and so we are quite convinced that a mathematician in Alpha Centauri will have worked out that the square root of 2 is irrational, or that there are an infinite number of prime numbers, and all of these things. So these are not physical things; they're abstract quantities which are the same everywhere in the universe. The interesting thing is in what sense they might precede the existence of the universe, but because we don't know how the universe came into existence, we can't really talk about that.
Yeah, we'll get onto that very shortly. So thank you for that, George. Interesting. So the fact that you could almost say that maths itself is a universal law that exists somewhere independently, like you just referenced with pi. So that's interesting in itself. The question you then raise in terms of whether it precedes everything in existence or comes out of everything in existence. Obviously, you can't really know the chicken and the egg in that respect. But to you, the main point is that mathematics, like pi, like any other exotic formula that people that aren't top level mathematicians would not be aware of, essentially exist independently in the universe.
Yeah,
That's
yes, it did. It's totally independent of physical existence. And just one comment on this. People sometimes say that mathematics has changed over time, which is true. But you have to distinguish mathematics per se, this abstract space, and
mm,
mathematics that we know. And there's a map from one to the other which changes over time. The one on the right, the mathematics per se, does not change in any way. The one on the left, the socially understood mathematics, of course, changes with time.
no, no, I completely agree. I mean, fundamentally, as you say, your reference of pi, there's a very good one. So pi from now to the future is just pi. You get practical workings on it that might adapt and produce new mathematics. I believe Ed Witten has done a lot in the mathematical space for string theory. So that's an example of evolving mathematics. But as you say, essentially, it doesn't change. So I agree with that, and that's fine. I don't know how much you know about realism and anti-realism in philosophy of science, but that's
Actually, it'll be quite fun to develop a theory where pi will have a different value in 100 years.
Yeah, exactly that, exactly that. Just your point there about the realism of mathematics. So in as I was saying, I don't know how much you know about realism and anti-realism in philosophy of science, but that point's also echoed with structural realism and anti-realism. So in philosophy of science, where theories change, as you would know, obviously as a physicist and cosmologist, where theories themselves change over time, that doesn't mean the underlying structure of reality changes over time. So obviously there's a slight difference in Newtonian gravity to Einstein's gravity, but the
Yeah,
structure is still the same. So
yeah.
I think that echoes your point about mathematics in general, which is actually very interesting. Now, let's get into the laws themselves. And the thing I find interesting about this is I've been speaking to, and I'm speaking to Paul Davies again on Monday, and he's got interesting work on the laws of physics in terms of where do they come from? If basically it's the question of necessity versus probability. If they had to be this way, why are they this way? If they could have been another way, but they're this way, so why are they this way and not another way in terms of probability? The reason I asked you this, and it was a good response you gave, you believe they are metaphysically primitive. Um, there's a lot of work in philosophy of physics here in terms of if you look at David Lewis's account, he doesn't really care about the metaphysics behind it because he's a human supervenience based on inductive logic from human David Armstrong and sorry, David Lewis would just say that laws are the things that supervene on a fact, so that he's not concerned about the primitive aspect of the laws. Barry Lower's got the package deal account, which is it's a practical working in a system that helps explain and construct reality that we can use for predictive tools. Again, a very pragmatic approach, not metaphysically loaded. Armstrong himself, the philosopher, just thought the laws were necessities between universals, but then that has problems for dynamic laws. A lot of philosophers and even physicists stay away from this area of I don't know where the laws come from. I know you knew Stephen Hawking obviously as well, and I think Stephen Hawking famously said you can't really ask what happened before the Big Bang because there's no time before it, so it doesn't make no sense. Like you can't ask what's more south than the Southern Pole. You and Paul Davies really think the laws themselves are metaphysically primitive?
But basically, yes, yes. We there's an interesting kind of thing that once you have the mathematical structures, basically you have scalars, vectors, tensors, spinors, and there's only a certain set of mathematical laws which obviously come out of them. And so at a certain level, once you've got the mathematical structures, the concepts, the laws follow out fairly naturally as being the simplest ways you can make stuff out of them. Yeah.
But as you say there, is it that the maths is from your perspective, and I don't know how much you thought about this as well, but I assume you probably have quite a lot. What's from your perspective, what's more primitive? Is it the mathematics and then the laws come out of that naturally? Or is it the laws that the mathematics then describe? Or is there no way to tell the difference?
I think I would say it's the mathematics which is the more primitive.
Fascinating, fascinating. That's interesting. And obviously, they could just so if they exist, so if the mathematics is more primitive than the laws and they're platonic and they exist
Yeah,
universally throughout the
yeah.
cosmos, could the mathematics themselves just have existed eternally, just indefinitely by themselves?
The word,
Yeah,
as
yeah,
soon,
yeah. Go
as
ahead.
soon as anybody uses the word infinite, they're on dangerous ground.
Yeah,
Um, I've written also about this that the concept of before the beginning is a faulty concept because uh, before doesn't exist before the beginning,
yeah,
then doesn't exist before the. So, because of our own experience, we're forced to talk in a way which really doesn't make sense. You have to, in some sense, lift yourself out to a higher dimension and look down on the universe in order for this all to make sense, and we can't do that. So we have no way to talk about before the beginning, before because time
yeah.
didn't exist then. So all we can say is we can look at this in some causal sense. Of course, the question is what is a cause, and some physicists deny that causes exist. Um, I take the view of causes in terms of difference making, and a cause is something, if you alter it, either experimentally or mentally, and it makes a difference, then it must be said that it's a cause.
Yeah, obviously you've got many accounts of obviously causation is so loaded. Obviously, what you're describing there are elements, obviously, of the interventionist theories of causation, which you'll be well aware of as well. Interestingly, you say that in terms of causation itself and that being problematic. So, Nancy, you described it as a difference maker. Nancy Cartwright, the philosopher of physics, describes them as an effective strategy. So when you do causation in social science models, you can then pursue an effective strategy. Say by adjusting economic inflation using this metric, you will see an effective outcome. But that's not the same as the point that you were making as well, which I'd adhere to as well. That's not the same as causation being some kind of fundamental property in the universe, of which Bertrand Russell very famously denied there's any kind of causation in physics. But if I can just pick you up here on this point, so whether it's the laws first and the maths that comes after it, or the maths first and then the laws are kind of coming out the maths, you suspect that it's the maths that are more primal. But then this is what's very interesting about this metaphysical question about what the laws of physics are and when they come from, because then you're basically forced into brute facts, and you've just elaborated on well what came before the Big Bang, or what was there before time? Well, nothing, because that's nonsensical. So, not to sound too defeatist, and this is a statement made by a lot of physicists as well. Do you think that it's almost impossible to know why the laws of physics are a certain way? I mean, it's just beyond our comprehension.
I think the best one can do, and I mean, it's nice you're pushing me on this, is to say that to be a law
Mm.
must be something where you can make predictions, and the predictions must be numerical predictions, otherwise you can't test them.
Yeah,
So,
statistically as well.
so the whole concept of a law involves the idea of quantities. And as I said, once you're doing this, there are some simplest laws, and there is a geometrical understanding about this, like the inverse square law comes basically out of the way that geometry works. Yeah, so I would place the mathematics first and the law second, but we're going to get to this, but I actually think in many ways the best way to talk about this is possibility spaces. And the possibility spaces are, in a sense, a way of describing what the laws of physics are. And a possibility spaces shows all possibilities for a particular system, like for a pendulum, you have a phase space showing how the pendulum can work. For for quantum mechanics, you have Hilbert spaces, which are all possible states of the quantum system. And the thing about a possibility space is it it's telling you how the laws lead to evolution. So you've got the laws, you've still got to know what evolution do they lead to, and the possibility space tells you what kinds of evolution and outcomes the laws lead to. And so at that level, they are much more useful. The laws of physics are getting at the outcomes, but the possibility space are already describing the outcomes. And that's why they're quite a good way to look at all this. And so they're possibility spaces of many kinds, in particular for physics. For instance, you can't travel faster than light. You can't get energy out of nothing. You can't have perpetual motion and all of these kinds of things.
So I think right now, because you've already addressed how you find the laws of physics to be metaphysically primitive, that you think it's likely that the maths is even more primitive than that. We've briefly touched on elements of probability and necessity in terms of mathematical necessity and probability in quantum mechanics. And because you've said it's very difficult to actually answer these metaphysical questions in the first place, I think right now would be a good time for you to discuss your possibility spaces in more detail. So obviously you've got the fundamental laws of physics. It's contentious as well whether they are deterministic and at what point they're deterministic as well. So we can get onto that if need be. So that Janine Ishmael thinks that physics isn't deterministic. Other physicists think it is completely deterministic. But essentially, and you can obviously elaborate this in more detail because it's your work, but you've got the fundamental laws of physics, and then out of that come possibility spaces. But these possibility spaces are obviously going to be constrained by the laws themselves. Obviously, just like
Correct.
you are sitting there in your office, you've got possibility spaces that you can work around, but you're still constrained by laws of physics. So if you didn't like that analogy, please tell me why. But if not, continue with the laws and possibilities.
So, sorry, we have got several kinds of streams going on. Well, one of them was whether they're deterministic or probabilistic. Quantum physics makes it absolutely clear that the universe is intrinsically indeterministic. Now, a whole lot of my there's a whole crowd of people out there trying to pretend this isn't the case and trying to say that quantum physics is deterministic, and that's just weird, given the two-slit experiment and
Yeah.
the decay of excited atoms. And so how they can deny that is quite beyond me, but nevertheless, they're trying to do that. So I believe in something that I call, or worked with my friend Barbara Drossel, called contextual wave function collapse. Wave function collapse takes place in a way which depends on the context, and we work that out in a great detail. Now, more important than that, there's a viewpoint that classical physics is actually indeterministic too. And this is because the concept of infinity is unphysical. Nothing in the physical world is unphysical, as David Hilbert said. And if you actually ask yourself, what's the most accurate measurement that's ever been made, and it's got maybe 15 decimal places. Now that is a definite chaotic dynamical systems. It simply isn't possible to send data in a way which, so the last, given your 15 decimal places, the one after that affects what happens in chaotic dynamical systems. And there's what Tim Palmer calls the true butterfly effect. And so, in fact, in reality, the ability to make predictions in classical physics is actually restricted just as much as in quantum physics. And the belief that physics will give you deterministic outcomes, it's simply a myth. And Nicholas Gizin is making this point at the moment, and quite strongly. And that there's a whole sort of offshoot of all of this, that the transition from calculus to analysis in mathematics, you gave in calculus you had a limit in going to infinity. In analysis you didn't do that. You talked about epsilons and deltas, and the transition when you gave up the idea of infinity and moved to analysis enabled you to do much more powerful mathematical theorems that you could ever. So the transition from calculus to analysis was a realization of the fact that infinity is not a great idea in mathematics as well as in physics.
Yeah, but I just wanted to pick up on one thing that you were saying about quantum mechanics and lots of people doing work trying to desperately, some would say that it's not indeterministic, that it's deterministic as well. And you find that quite strange. So one about the contextual wave function. So I suppose there's lots of work going on in this area, and I could give some examples as well. But before we do that, let me give you a quick question. Do you believe the wave function actually exists ontologically? It actually exists?
That's a very good question. I think I'm agnostic on this. I tend to feel it does, but it relates back to the mathematics which you were talking about. But I want to go into this desperate attempt to save the collapse. It's much worse than that. They attempt to say that everything is described linearly, because there's now a lot of talk going on about the wave function of the universe, which is described by. I've written a little paper on this, which I think is really quite important. I think this is a fundamentally flawed concept. I do not believe a wave function of the universe exists, wave function of a cat, wave function of a brain. What I believe is they're the same as in general relativity. In general relativity, in general, you cannot find a global coordinate system for a space-time. What you can find is local coordinates, which you patch together to be able to describe what happens to the thing as a whole. And I believe that that is the true way to handle what happens in quantum physics. There is no wave function even for a cell or whatever. There are little local wave functions everywhere. And so quantum physics is linear everywhere, and you get the nonlinearity by patching together in nonlinear ways. If you check up on Google Scholar, you'll find my recent paper on that. And it's just mind-blowing to me that people can try to say, which they basically are doing, some of them, that the universe evolves linearly. If I do that or that, I've proved the universe does not move linearly.
No. Thank you for that, George. There's also other work going on here as well. I will actually send you the thing because obviously I'm not trained in physics to an advanced degree. I am trained in advanced degrees to philosophy and social science. So that's the only appreciation. I have no advanced degrees in physics. So I'm going to send you a thing because obviously you can understand it more than I will. But in terms of this desperate attempt of people running around playing with different theories and models of quantum mechanics, I was speaking to Jacob Barandis at Harvard, and he's got a whole research program and a few papers out, but basically employing the current classical mathematics to quantum mechanics, and where it's not necessarily quantum mechanics doesn't necessarily become indeterministic, it becomes deterministic as well. So if you may already know that work as well, if you don't, I'll send it to you. You'll find it interesting. I'm sure you probably won't like it, but you'll definitely be able to make more sense as a physicist and mathematician than most people. That's Jacob Barandis in terms of um, he doesn't believe in the wave function either, but neither does Eddie Chen, and that's fine. And Roger Penrose, to a certain extent, questions a lot of quantum mechanics anyway. That's not really that surprising to people. But what's very interesting is the employment of classical mathematics in the quantum space as well, which is really for mathematicians and physicists. So I think you'll find that paper quite interesting.
Thank you.
Continue on your track about possibilities, how they shape the universe. Obviously, they come out of laws, but
Well, let me give you a particular example of possibility space. There's a wonderful little book by Andreas Wagner called Arrival of the Fittest. And for instance, and this relates to the Nobel Prize, is there's a possibility space for proteins.
yeah,
And
yeah.
it's a very, very large space, and it can be explored. The Nobel Prize is for exploring it. And now that possibility space derives from the underlying physics. Okay, but there's a possibility space for animals. Animals can't run faster than light. They can't. If you scale
Yeah,
up
yeah.
until it's 20 foot long, it'll collapse because of the force of gravity. And so there are higher level possibility spaces which derive out of the fundamental ones. But then there's this issue where you and I have had a bit of a disagreement. There are some possibility spaces which are independent of the underlying physics. They've got nothing to do with them.
So if you believe that the possibility spaces aren't actually related to some physical spaces, how do you marry that with everything ultimately being physicalist? Because it's a metaphysical issue going on there.
While some possibility spaces are related to the physical, and you can include in that things like the possibility of Darwinian evolution
Yeah.
taking place, things like that. Although there is a problem there that physics does not understand the concept of being alive. And so there actually is quite a big problem there claiming that physics can tell you anything about biology in that sense. But the key one, which I have emphasized and I'm going to re-emphasize, is that there are some possibilities which are not based in the laws of physics, and these are logical possibility spaces. And the one which I think is simplest because it is clearest is the space of computer algorithms. And computer algorithms are abstract entities. They are a set of rules for manipulating symbols. And symbols are the core of computing. And computing is about symbols. And Dasgupta, in his little book about this, says there's three types of causality taking place in computers. There is physical causation, which is electrons going through. There is abstract causation, which is which is following the logic of the algorithm. You feed in some data to the algorithm, you run the algorithm, and there's nothing physical about that. That's all purely abstract thing which is taking place. An algorithm is not made of metals or coal or electrons or anything. And then he talks about liminal causation, which is where the abstract becomes physical. And this happens through the construction of a computer. And you feed in the algorithm at a high level language, and it chains down through a series of compilers until it is a machine language. At that point, the machine language is converted, its ones and zeros are converted into electrical currents, and that's where the liminal causation takes place. So you get physical causation, but it is driven by the algorithm, which is a purely abstract thing. And it's crucial to recognize that the algorithm is itself abstract. And so this is an example of causation which is not based in physics. It is caused by an abstract entity, which then makes the physics do what the abstract thing says it ought to do.
So that element of the algorithm that you just give an example of that, is that an example of a possibility space for you?
There is a space of possibility algorithms, of possible algorithms.
So the other possibilities that you've just given in terms of possibilities for animals, possibilities for proteins, you said they are constrained by the laws of physics. But in
Yeah.
this respect, certain algorithms that have possibilities are not constrained by the laws of physics.
No, they're constrained by the laws of logic. And this is what computer scientists do. Computer scientists work out how to use the law, and you use Boolean algebra to work out Boolean logic to work out, and in fact, computer scientists do this. They use Boolean logic to work out how to make the logic work out and control the physics. And so what underlies this is logic, and which is not physical.
Okay, perfect. And then this is going to be my next follow-up point because that's clearer to me now, your position. And I think it may be to do with this. So the reason this works for you, and this is what we were discussing previously by email in terms of a physical realization, where you think some things aren't realizable or reducible to the physical. So we're going to have the laws of physics, and they're going to have possibility spaces. And some of these possibility spaces are constrained by the laws of physics. And then you've got other possibility spaces which aren't constrained by the laws of physics and physicalism. They're just constrained by abstraction in terms of, obviously, as you said, algorithms. There's going to be, if I may quickly, George, there is going to be an issue there of marrying the two unless, and I think you already touched on this already, you believe that the abstract realm really does exist in itself independently.
Yes, I do.
Yeah, so that's the thing. So that makes sense. And then you're going to have certain philosophers that will say there's a tension in that metaphysical reality where really metaphysically there's only one underlying reality, as where you think there's more than one. Or you could be someone, and I don't think you're a panpsychist, so I won't get into that. But you could be someone like David Chalmers who thinks that the current scape of the scientific picture is incomplete and that it isn't physicalism and abstraction, it's something else. Or you're happy with there being two metaphysics, even though that could be contradictory, because you believe in the abstract realm. And Sean Carroll and others will be, no, the abstract realm is just reduced to the physical realm. You're like, no, there's the physical realm and there's the abstract realm. And then some are going to say, well, no, you can't have both simultaneously. That's somewhat of a contradiction. Or you could have someone like David Chalmers, which is like, I don't think any of these are right. We're missing a bigger picture. But you essentially believe that there are two realms, a physical realm and an abstract realm.
Yes.
Okay,
yes.
okay. And we won't get into whether that's a metaphysical contradiction right now. I don't know. But you obviously a physicalist in that respect, clearly, because we discussed this previously. That's very interesting. So you really...
Well, I'm going to up the ante in a minute.
No, but up the ante now. Go ahead, George. Go ahead, yeah.
Okay. Well, the ideas are abstract. So I can have an idea of something, and that is an abstract thing. And what I haven't emphasized is multiple realizability. So I can have an idea of an iPhone. Okay, now I can talk about it. I can have a diagram about it. I can have a photograph of it, and so on. And the point about an idea is that they're multiply realizable, and they're not the same as any particular realization of that of it. It's the whole equivalence class of representations, and it's the same with a computer program. Your algorithm can be realized in many, many different programming languages, and that can be realized in many different chips. And as you go down, there are many, many different ways it can be realized. But the thing which is character, in fact, is quite extraordinary. The logic of, I like to use bubble sort as an example. The logic of bubble sort chains down and gets rewritten in different languages at different levels in the computer, but it's always the same logic. And it then gets implemented in terms of ones and zeros. Now, if you're just looking at the ones and zeros, you won't realize it as bubble sort taking place, but it is being driven downwards by the fact you loaded that. Now, the upward escalation is to say that this applies to ideas, and there's a possibility space for ideas, for all ideas. And this possibility space is described beautifully in Borges' The Library of Babel, that wonderful, wonderful book. And in the Library of Babel, every possible idea is written down. Every possible idea is written down, okay? So there's a possibility space for ideas. And again, that possibility space, and I want to emphasize this thing. the point about these possibility spaces, they're the same everywhere in the universe. So you've got a philosopher over in Alpha Centauri. He'll have the possibility of thinking the same ideas as yours. And the reason he can think about the same ideas is because there is a possibility space for philosophical ideas. And you know a lot more about that than I do. So I think that Borges' idea that there's a possibility space for books. Now, one thing to emphasize, this thing about infinity comes back into this again.
Yeah.
Because some people say, but you can have infinitely long sentences and so on, and that's a load of rubbish. And what the people who say a sentence can be infinitely long forget is this. By the time I reach the end of the sentence, I must remember the start of the sentence, which means that the length of the sentence can be at most, let's say 150 words, or let's be generous, 700 words. And so when people talk, and this is built into the Library of Borges, all of those books are finite books. So he doesn't talk about infinite. And so the idea of infinity not relating to physical reality is inbuilt into what I'm just saying. Given that, there's a space of possible ideas, which is an incredibly large space, but nevertheless, it contains all possible ideas.
Thank you, George. There's two things I'll pick up on there. Firstly, multiple realizability is an interesting area in itself. Obviously, Hilary Putnam did a lot of that as well. Just to give you an example of how that came about. So one of the areas he was working on, I believe, in the 1970s is this idea that, as you were saying, you can have multiple ideas that have a possibility space and aren't reduced to one single point, hence why you have multiple realizability. And this was echoed by the philosopher of mind, Kim. So their argument is, and this is what we can get into in terms of whichever way you pull it apart in terms of metaphysical primitivism for the laws of physics, where do they come from? There's certain elements that you can't escape, and we've already discussed how causation may or may not be fundamental. There's certain things you can't escape with cause, sometimes temporal symmetry, and identicalism. And this is picked up quite nicely when I make this example about multiple realizability. So you give a multiple realizability for multiple possible ideas that aren't reduced necessarily to one physical space. Hilary Putnam is saying if the mind is completely reducible to the physical brain, that would mean that in terms of multiple realizability, there are many ways that you could generate an abstract space of the mind using different physical quantities. And that echoes a similar point that you were saying in terms of from one physical quantity, you could get multiple realizabilities. So that's where that work comes from Putnam. Now, what people that have done physical realizability, such as Sidney Shoemaker and Andrew Melnick have done is they've tried to water down that multiple realizability to having one level of physical realizability. And that's to do with supervenience and human supervenience. So an idea for them, I know you won't agree with this, an idea for them is an abstract entity that can be realized in a physical quantity in terms of supervenience, which means if you change the physical quantity, you must in some capacity change the realizable idea. So it's far more constrained than multiple realizability. The charge against that is, well, if you're just doing that supervenience, then you'll either have to address a cause, in your case, why there's multiple algorithms that are being caused by a physical quantity. That's why you don't actually ascribe to that. Or you have to just say that they're identical to it. And a lot of these issues about supervenience, causation, identicalism boil down to those three elements, because if you're going to do multiple realizability, you would say that there's a physical structure and there are possibility spaces. You can have multiple realizability. So really, the physical structure, as you're saying, isn't necessarily the same as the abstract structure. If you're a physical realizability in a monolithic sense, you would say, no, it is that just in terms of supervenience, so you change quantity X and you change this idea here. But you see, a lot of these issues are to do with, is it being caused? Is it identical to it? Does it supervene on it? Or is it distinct? And in your case, it's distinct. The abstract is distinct from the physical quantity. Sean Carroll would say something completely different. But they're the important issues of it. So when we were discussing this earlier, I think emergence is generally completely fine. It's just what is the ultimate physical reality behind it. And for someone like yourself, you're not too concerned because you really think there's two realms. You think there's the abstract Platonic sense and you think there's a physical sense. But it just goes to show how difficult and loaded these topics are in physics and philosophy.
Yes. Look,
Yeah, that's
I'm a physicist. I'm not a philosopher.
but the thing is, this is so I'm sure you know Carlo Rovelli, the quantum loop gravity expert. So he was talking to me about how obviously how lots of physicists ultimately have to be philosophers, and I think you'd be a very good one in terms of your metaphysics of the laws of physics, and Paul Davies as well. So yeah, there's an intertwine between the two. And I just wanted to get one more thought on you in terms of infinity, and I think this is ironed out by some of your work. So for you, you've got the physical reality and you've got an abstract reality. Now, in the abstract reality of mathematics, as a good example, you have infinity there, but in the physical world, you don't have infinity. Some
Yeah.
would say that's a bit of a tension, but you don't think so because in the abstract world, it's independent to the physical world as well. So is that right? So for you, there's no tension with infinity existing in the abstract realm, but not in the physical world. That's fine with you.
Yeah, there's a subset of the mathematical world which applies to the physical world. That's basically what David Hilbert said. So particularly there's all of this stuff about multiple different kinds of infinities. I simply can't get interested in that. And actually, the way I like to think of this does relate to physics. If I hold my two fingers 10 centimeters apart, I do not believe there's an infinite number of distinct physical points between them. So I believe that space-time is quantized in some sense,
Mm.
and so that finity is not there.
Infinity in the abstract mathematical sense starts off with bits of set theory, so you can keep adding one to a class of numbers. But in the physical space, the example you're giving with the fingers, obviously there's no infinite space there as well. That's very well put. Is there anything else you want to mention on the laws of physics, infinity, or emergence? Is there anything else you want to mention?
Well, yes. Look, the key. I've spent a lot of time looking at how biology arises out of physics, and the key concept is downward causation. Now, I gave an example in the case of digital computers. Its downward causation takes place in the physical hierarchy and in the logical hierarchy. And so there's physical and logical hierarchies. And in biology and generally, there are basically two different types of downward causation that takes place. And very briefly, one of them is time-dependent constraints. Um, you turn on a switch and the light goes on. That's because at the macro level, you've changed the switch, and that changes the topology of the circuit. At the micro level, it causes electrons to flow as the light goes on. That's top-down causation by time-dependent constraints. And the other one is by downwardly changing the elements you act on. And this is absolutely central to biology. All the time, gene regulatory networks are creating new proteins which didn't exist before. In developmental biology, you have cells which are pluripotent and then they specialize to become bone or marrow or whatever. And this is why in the minds of a lot of physicists, they think of emergence in terms of the kinetic theory of gases, and you've got these things banging into each other. And these things are not affected by what is happening. In the real world, these things are affected by what is happening. And that's what makes all the difference in the world. And so what happens at higher levels changes. They don't change the laws, they change the things that the laws act on. And that's absolutely clear. Now, where that fits into physics is by the creation and annihilation operators of quantum field theory. And one of the strange things about all of this, so we know that particles are created and destroyed. And what that means is that the particles you start off with are not the same as the particles that you end up with. And that's one of the reasons that predictability is very difficult. And one of the very interesting things, if you look at quantum field theory books, you'll find in great detail a description of this process of, well, particles in quantum field theory are they're not actually particles, they are particular ways that the fields are set up, that their particular field configurations. What you don't find is a description of when particle creation takes place and when annihilation takes place. And it's a very big, and I may have missed the literature that talks about it, but it's absolutely central to what's going on. If you want to predict from now what's going to happen, now you need a prescription when a particle is going to be created. And I haven't seen such a description in the literature of quantum field theory.
That's very interesting in itself. So that's a very good example there of some anomalies and missing information in particle physics in that respect. I think ultimately this is a contentious issue in terms of metaphysics or physicalism and a metaphysics or physicalism versus anything else. So in one respect, top-down causation, you're happy with that because there are two realms, the physical realm and the abstract realm. Some are going to say that's already a metaphysical contradiction. You can't have two entities going on there, just like you can't really have a God and the conservation of energy. That's one thing. Another person would say the fact that you can have top-down causation is because there is a feedback loop and it's all one physicalist system, but you've already said why it's not. So really it's about how many is metaphysical duality, so to speak, possible? And if it's not, then how do you go about repackaging top-down causation, of which some of it may be a feedback loop, or some of it may be the fact that it's supervenient, not necessarily causation, just it supervenes on it, so it moves in tandem and it changes. So a lot of these issues in emergence, even though I think
you repackage top-down causation in the terms of the language of Aristotle's four kinds of causation, which I have done. And Aristotle was right on the mark with all of that. And I've written what I think is quite a good paper about this. So you go back to Aristotle's causation. What I thought you would try to get me on, and you haven't, is if these are abstract spaces, how can the human mind apprehend them? And it turns out there's a wonderful book about that by Paul Churchland called Plato's Camera. And Plato's Camera is a fantastic book. And its subtitle is How the Human Mind Can Apprehend Abstract Spaces. And it's exactly about this. And so some people say, look, it's all very well talking about that, but the human mind couldn't comprehend them. And Paul Churchland's book tells you precisely how this works. It's a great book.
With that argument, I mean, I've got no issue with that because Paul Churchland himself and his wife, Patricia Churchland, are severe physicalists in the first place. I mean, they really are quite ardent physicalists. So this is what I'm saying. So to those kind of thinkers, it's not really an issue of how the mind can perceive abstract spaces because the mind is ultimately physical. So that's what I'm saying. There isn't anything particularly concerning to them. You think so. To someone like the Churchlands, although Patricia Churchland is more aggressive than Paul Churchland, she's obviously a mental eliminativist. She doesn't actually believe in a mental. For them, you can have this abstract space of the mind, but that is still reducible to the physical brain. That is either realized in the brain or literally just identical to a brain state. You're saying, no, there's two different possibilities. There is the abstract world and the physical world. So it depends whether you believe that there's more than one metaphysics, so to speak, or you could have two ontologies, a physical world and a mental world. And that obviously gives rise to the combination spaces and the combination problems in philosophy of mind. As to the abstract world and the algorithms, as we were discussing before by email, I think the algorithms and computer science in general, ideas, art, creativity, design behind buildings, I think that's all fine and can emerge, and they could even have a top-down cause. It's just to what extent they're realizable or not realizable in physicalism, and then that creates issue whether if they are, then that's only one metaphysics. If they're not, that's two metaphysics, and is that a contradiction? Which this isn't the only space it happens in. It happens in physicalism versus the mind. So yes, very very loaded.
I haven't thought this through properly. It's possible I might become a dual aspect monism person if I thought about it long enough. But I want to insist on one thing, that ideas are abstract.
Yeah.
and they have causal powers. And um, and this is simply obvious. If it wasn't true, you couldn't explain why the computer exists on which we're talking. And so ideas are an idea isn't a physical thing, it's realized physically, but it's not itself physical. And so this idea of realization is crucial. And I don't believe that everything is conscious. I'm not a panpsychist or anything like that.
You've been striking this one.
I think you need a certain level of emergent stuff you need a brain. If you haven't got a brain, and I'm afraid I think, much as I respect Roger Penrose, I think he's trying to get at emergence at completely the wrong emergent level. Emergent consciousness doesn't reside in an individual neuron or even smaller scales. It comes at the emergent level in terms of circuits at the scale of the brain as a whole. It doesn't reside at any smaller level.
If you look at, there's a lot of work in mental causation, of which Barry Lowe is one. So I find it very difficult to deny there's an element of mental causation just by the fact that I've caused this cup to be picked up. So that's mental causation right there.
Exactly, precisely.
The feedback. I mean, it's very difficult to do that, even despite, I see people in philosophy of mind have tried to do that away by saying that it's subconscious processing that I've already decided at a physical level before I've consciously decided to pick it up. But there's still an element there that you can't get away with. There's something in my psyche, even if it's happened 10 seconds before, that I'm still deciding to cause it. So many people have tried to get away with mental causation by going, no, it's just subconsciously you decided that 10 seconds ago, now you don't know, which still doesn't really eliminate the mental for me. That's point one. An idea clearly exists in an abstract realm. Hence why, as scientists as well, there's a reason you know ideas can exist abstractly, is because not all ideas are correct, not all ideas work, but they're generated, and some can be very wrong. For example, I've just had the idea that the world was created by a pigeon. That's obviously not correct, but it's still an idea. So the idea was independent of a physical reality in that respect. Whether they're realized on it is a different issue, which I think we've got some agreement on there. As to your point on emergence coming out of consciousness and emergent property coming out of a collection of neural networks, I think that's also fine, and many neuroscientists would agree on that. So the whole is more than a sum of its parts, and I think that's been kind of borne out by a lot of neuroscience. So
yeah.
when you have a thought that exists at one moment in time, it's a collection of different neural firings happen, and that is an example of an emergent property of totally one experience consciousness, like me speaking to you right now, but with different firings of different bits of my neural networks. So that's a great example, which I agree with in terms of emergence coming from something that's physically realized. And it's more than the sum of its parts. And Neil Seth, in my interview and discussion for the Montreal Review, will agree with that as well. A lot of it, though, unfortunately, will get down to when we talk about it's realized in the physical, what do we mean by that realization? And that can be a bit loaded. But I think emergence in general is very interesting. And it's, I think, quite clear that it does exist in certain fields. Evolution, Darwinian selection pressures, the whole host of the social sciences and economics, obviously decision-making, rational choice theory, consciousness and the mind, and the overlap between maths and the physical world, even if you don't think maths exists abstractly. So they're my thoughts on it. So I think the area of mind is very interesting for emergence as well in general. And I don't think you can just get rid of the mental like that. And I think there's clearly mental causation.
I want to just make one comment on that, which is obviously we are conscious. The people who deny consciousness are just ridiculous. And my position is that there is a hard problem. We understand a huge amount about the neural correlates and all that kind of stuff. I don't believe we even know how to begin solving the hard problem. How do you relate the interior and the exterior? Yes, of course, a lot of subconscious stuff is taking place. We've known that since Freud's time. There's nothing new about that. But there is a level of stuff in which I do make choices. and one can go into that. But the difficult one, the really difficult one, is how I see you, hear you, feel pain, and all that kind of stuff. And I really don't think I've even begun to understand that.
I'm actually in the middle of all this heated discussions with Michael Graziano at Princeton, a neuroscientist who dispels consciousness, doesn't believe in it. Frank Jackson, I'm also currently speaking to him, the famous Mary's Room thought experiment, where he tried to initially prove that physicalism was wrong and then later reverted to physicalism, denying qualia, and Keith Frankish on illusionism. What I'll quickly say is, I'll send you the published article afterwards, is what they mean by that. This is like moving the goalpost. They don't mean that right now when you're speaking to me and you see Tony and you've got an inner world, they're not denying that. What they're denying is the phenomenological property that there's something above and beyond your experience. So qualia isn't something that's detached from the world. Your experience is just representing the world in a functional knowledge way. So that goes into semantics, and they're just moving the goalpost, because David Chalmers, what you would say, and to a certain extent what I would say is, okay, so qualia doesn't necessarily have to be an intrinsic phenomenological property, but the element of experience, or as I say, sensational realism, is still there, and that still is a bit of a problem, even though they're going to repackage it in other ways. So I think many
Yeah.
people would agree with what you said as well, even though many illusionists are trying to get out of it and saying, well, we're not denying that, but we're denying this. And most people are like, it's still a sensation. So